All right, everyone, this is your Chapter 4 review video. Since we took all notes this chapter, I made a quick recap for you of the main ideas. This is not an exhaustive list, so please make sure you do the review packet and check your answer key, but these are the types of problems you need to be able to do on your test. So in section 4.1, remember we started off talking about degrees of polynomials and what that tells us about their roots. So, for example, here's a polynomial 5x minus 2x squared plus 3. When I want to talk about the degree, I want to look for the exponent that has the highest value. So that's going to be the negative 2x squared. So the degree of this polynomial is 2. The leading coefficient is the number in front of that term, which is negative 2. And remember that the number of roots corresponds to the degree. So there are going to be 2 roots in this polynomial. They are complex roots, meaning they could both be real or they could both be imaginary. Then we wanted to say, if I gave you the roots of an equation, could you then find the equation? So remember that we have something called complex conjugate. So anytime we have an imaginary root, its complex conjugate is also a root. And when I'm given roots, these are the places where I have zeros in my function. I want to change the sign and say x minus 6, x minus 2i, and x plus 2i. Those are my 3 roots written in factor form, and then I'm just going to multiply these out. So first I'm going to FOIL the 2 that have imaginary roots. I'm going to carry down this x minus 6. This is going to be x squared minus 2ix plus 2ix minus 2i squared. Our 2ix terms will cancel. Recall that I squared is negative 1. So this is really x minus 6 times x squared plus 2. Because negative 1 times negative 2 is going to give me positive 2. And then I'll FOIL the remaining terms. So I'm going to have x cubed minus 6x squared plus 2x minus 12. So this polynomial, if I were to find the roots of it, would give me 6, 2i, and negative 2i. So that's just working backwards. All right, and then in 4.2, we talked about solving quadratic equations. So we did that by graphing, by completing the square, by factoring, or by using the quadratic formula. So we're going to look at a quick recap of completing the square and the quadratic formula, and hopefully we will get the same solution. So recall when we're completing the square, the first thing we need to do is make sure that our leading coefficient is 1. If not, we need to divide through by whatever that is until we get a coefficient of 1. Then I need to take the second term, 13. I'm going to divide it by 2. And then I'm going to square it. So that's going to be 169 over 4. So on this, the left-hand side of the equation, I'm going to have x squared plus 13x plus 169 over 4. And on this side, I will have moved the 30 over, so I'll have positive 30 plus 169 over 4. Remember that this side of the equation always factors into x. The sign is plus, so it'll be plus. And then I'm taking whatever I did to divide b by 2 before I squared it. So it's going to be 13 halves squared. On this side, I'm going to need a common denominator. So 30 times 4 is 120, plus 169 gives me 289 over 4. And then I need to take the square root on both sides. So I'm going to root both sides. I'm going to get x plus 13 halves equals plus or minus. The square root of 289 is 17, and the square root of 4 is 2. So those both come out of the root. And I'm going to move the 13 halves over. So I'll have x equals negative 13 halves plus or minus 17 over 2. Now, this is a nice answer because I don't have any roots or imaginary numbers, but I do need to simplify this. So I need to say negative 13 minus 17 is going to give me negative 30 halves, which is negative 15. And then negative 13 plus 17 is 4. 4 halves gives me 2. So my two solutions are negative 15 and 2. Now hopefully when we do the quadratic formula on the same problem, we should get the same thing. So recall in this problem our A is 1, our B is 13, and our C is negative 30. And our formula is B squared, negative B plus or minus the square root of B squared minus 4AC all over 2A. So plugging those in, I'm going to have negative 13 plus or minus the square root of 13 squared, which is 169, minus 4 times 1 times negative 30, all over 2 times 1, which is 2. 169 minus 4 times negative 30 is going to give me 289, which is square rooted 17. So again, I have negative 13 plus or minus 17 over 2, which will give me my identical answers, negative 15 and 2. So again, on your test, if I tell you to solve it a certain way, you have to use that method. If I give you the choice, then you can choose whichever one you prefer. Okay, we are going to now determine the factors of this polynomial. So this was in 4.3 where we revisited the concept of synthetic division. So remember that if I give you a factor, that's the number that you want to put in the synthetic division box and then divide so that your remainder is 0. If I don't give you a factor, then you need to test all the factors until you find one that works. So I want to look at 4, and I want to figure out what are all the positive and negative factors of 4. So I have plus and minus 1, I have plus and minus 2, and I have plus and minus 4. And I'm going to test these out until I find one that gives me a remainder of 0. So I haven't done this in advance, so I'm not sure what's going to work, so we're going to try one out. So let's try 4, see how we do. So my coefficients are 1, 1, negative 4, and negative 4. I'm going to put a little box for my remainder, which I'm hoping will be 0. So I'm going to carry down my 1. 1 times 4 is 4. Add that together, that's 5. 5 times 4 is 20. 20 minus 4 is going to be 16. And I can already tell that's not going to give me what I need. So let's try something else. Let's try negative 4. 1, 1, negative 4, negative 4. This is 1. 1 times negative 4 is negative 4. 1 plus negative 4 is negative 3. Negative 3 times negative 4 is positive 12. And 12, negative 4 plus 12 is going to give me 8. Again, not going to work. Okay, let's try 1. 1, 1, negative 4, negative 4. Okay, so 1 times 1 is 1. That gives me 2. 2 times 1 is 2. This will give me a negative 2. Negative 2 times negative 1 is negative 2, which gives me negative 6. Again, not my number. I should have done this beforehand. I'm sorry. Alright, let's try negative 1. 1, negative 1 gives me 0. 0 times negative 1 gives me 0. Here we go. Negative 4 times negative 1 gives me positive 4, which gives me 0. Okay, so x minus, negative 1 is a factor, so x plus 1 is a factor. And then this polynomial, my depression polynomial, is where I'm going to find the rest of those. So this is going to translate into x squared plus 0x minus 4. So this is a difference of squares. This is x minus 2, x plus 2. So my three factors are x minus 1, x minus 2, x plus 2, and my zeros are going to be negative 1, negative 2, and positive 2. All right, in 4.6, we did two types of problems, solving rational equations and then decompressing into partial fractions. So the first thing we want to do always is figure out what's our least common denominator. In this case, it's going to be b plus 5 and b minus 3 because they share nothing in common. So I'm going to multiply both sides of my equation by b plus 5 and b minus 3. When I do that on the left, the b plus 5 cancels, and I'm left with 9 times b minus 3. On the right, my b minus 3 cancels, and I'm left with 3 times b plus 5. And then I'm just going to solve. So this is going to be 9b minus 27 equals 3b plus 15. I'm going to move the b's to one side. I'm going to have 6b and move the 27 over, and I'm going to get positive 42, divide by 6, and b equals 7. I want to check that solution, making sure that it doesn't make any of my original denominators 0, and it doesn't, so I can keep it. So when we want to decompress the polynomial, remember our first step is to look at the denominator and see how it factors. So this factors is a difference of perfect squares, x minus 2 and x plus 2. So I'm going to put in some placeholders and have a over x minus 2 plus b over x plus 2 equals my original rational expression. Okay, and again, I want to get my LCD and multiply through. It's always going to be whatever you had factored into here, x minus 2, x plus 2. When I multiply through, the first term, my x minus 2's cancel, and I'm left with x plus 2. The second term, the x plus 2 cancels, I'm left with x minus 2. And on the right-hand side, m squared minus 4 factors into this, so both the factors cancel, and I'm just left with my numerator. Then I want to eliminate a and b individually to solve for the opposite variable. So to eliminate a, I'm going to let x equal negative 2. When I do that, I have a minus 2 plus 2 plus b minus 2 equals 5 minus 2 minus 4, and obviously by x, oh gosh, I'm mixing all my variables here. Let's make that an x and that an x, even though we started with m's. Sorry about that. Okay, so my a goes away. I'm left with negative 4b. I'm left with negative 14, it looks like. So this is going to be b equals 14 over 4. Normally I'd say leave your answers in fractions, but because this is a fraction within a fraction, right, b is my numerator, let's just go ahead and make that a decimal. So that's going to be 3.5. Now to eliminate b, I'm going to let x equal positive 2. So I'm going to have a equals 2 plus 2 plus b equals 2 minus 2, getting rid of that, and 5 times 2 minus 4. So b goes away. I'm going to be left with 4a equals 6. A equals 6/4. And I'm going to write that as a fraction, 1.5. So I'm going to have, over here, I'm going to have 1.5 over x minus 2 plus 3.5 over x plus 2 equals my original expression. Again, I generally will keep your answers in fractions, but if it's a fraction within a fraction like this, go ahead and make those into decimals. Okay, and then the last thing we did was solving radical expressions. So our first step here is to isolate the radical on one side and then square the equation or cube the equation to get rid of it. Now when I have two radicals, I'm going to need to do that process twice, and I'm going to start by getting at least one of them by itself. So I'm going to move the root a minus 3 over. I'm going to have a plus 4 equals 7 minus root a minus 3. And now that my left-hand side is isolated, I can square both sides. So here I have a plus 4. And remember, this I need to FOIL out. So this is really 7 minus a root 3 times 7 minus a root 3. So I'm going to have first terms give me 49. Last terms give me minus 7 root a minus 3. Inner terms give me minus 7 root a minus 3. So together I have minus 14 root a minus 3. And then I have minus, and minus is going to give me a plus when I multiply my last terms together. So that's going to be plus a minus 3 as my radical sign disappears. So I want to see if anything cancels here. An a on this side and an a on this side are going to go away. I have 49 minus 3, which is 46, and move that to the other side is going to give me negative 42 equals negative 14 root a minus 3. 14 does go into 42 evenly, so I will divide by that to get rid of it now. If not, I could leave it there and just square this side. This is going to give me 3 equals a minus 3. Now I will square each side again, giving me 9 equals a minus 3. I'm going to move the 3 over and get a equals 12. And remember, I always have to check my solutions here. So if a is 12, then I'm going to have root 16, plugging back into the original, plus root 9 equals 7. This is 4 plus 3 equals 7. 7 equals 7. So that answer checks out, and I can keep it. All right, and that is all we did this chapter. So get started on your review packets. Make sure to check the solution online. And I will see you at Flex tomorrow to last minute study before your test. All right, good luck.